if you're using containers or more specifically Docker, I would stick around for this because there's something new on the horizon that's coming soon. Hi everyone, my name is Fani Reinders. Welcome to my channel once again. This is the channel where we dive into the latest news and also all the great bits of .NET and Azure. So do follow along, and if you like the content, please comment down below, give me a thumbs up, and do hit that subscribe button. Oh yeah, and you can also hit the little bell icon the next time I post a new video. So, Docker. I'm not saying Docker is dead, right? It's more like a sense of Docker was good in the past, but now there's a new kid on the block here, bringing your attention to the following. So this tweet was kind of tweeted in 2019 when Lynn Clark announced WebAssembly outside the browser. So for those that's not familiar with WebAssembly, it's kind of a sandbox environment in the browser that is accepted by the W3C as a standard for browsers, right? So running a binary format, WASM, inside the browser is a thing. And that was kind of back then, 2019. And this tweet from Solomon Hykes, which is the co-founder of Docker, this was in 2019 as well, it kind of shook the cage a bit because the co-founder of Docker tweeted out that if WASM and WAGI, I will get to that in a sec, existed in 2008, we shouldn't have to need to create Docker. That is how important that is. And WebAssembly on a server just makes sense and is the future of computing. A standardized system interface was missing link. Let's hope WASI is up to the task. Now, a standardized system, which is WASI in this case, WebAssembly System Interface. And the whole beauty of WASM and WAGI together is super, super powerful, because in the past, WASM alone, it's just like a Flash component really, right? It runs in the browser sandboxed. But WASI is actually creating a standard for these kind of things, which breaks through the browser. Now you can run these kind of images. If it's compliant with the WASI standard, you can run literally anywhere. And it turns out, another latest tweet just a couple of days ago from Solomon again, the Docker and WASM announcement makes perfect sense. We no longer have to live in a single runtime world where there are Linux containers, Windows containers, and WASM containers. OCI can package them all. The OCI is the Open Container Initiative. It's a kind of initiative to strive towards an open container ecosystem. And we should be able to run them with Docker. Now, the announcement of Docker and WASM is huge. So I'm not saying Docker is dead. It's just mutating into a different direction, adopting WASM, right? Which is really, really, really awesome. So now you have WebAssembly images that can literally run anywhere. So if you look at Docker and container, etc., your vanilla approach to containers is that your image is compiled for a specific operating system. So although you can have your code compiled once, you kind of wrap that application around a Docker image that is built specifically for a OS like Linux, Windows, and whatever. What is a game changer here is if you use WASM, then you can actually just compile it once and it will run everywhere. So that same image you put on the store can literally run everywhere, which is very, very cool. And I want to actually point your attention to Fermyon. I hope I said correctly. So Fermyon has a cloud native framework called Spin that they're busy working on to kind of create WebAssembly native applications for microservices. This is huge. So do check it out. I will link all these things in the comments down below for you guys to check out. If you're also asking, why should you care? Well, the thing is, there's an organization called the Byte Alliance. Now, it's an organization of a bunch of companies that make sense. Microsoft, Google, Amazon, all the big boys are in this club, and also Mozilla, right? They form the Byte Alliance, and the Byte Alliance is the kind of a body that kind of drives the initiative of WASM and WASI, etc. So it just makes sense. And the announcement of Docker with WASM also included that they would also join the Byte Alliance. This is big news. So it turns out that .NET can also be compiled as a WASM file. We all know that, probably because WASM is kind of a nature thing in Blazor. Blazor that runs in a browser uses WASM files. So if you remember that, I'm going to quickly show you a way how you can use a normal console application in a WASI environment. So let's say we have a normal console application. Let's create one, .NET new console, and we'll output this as my WASI app. In a sec, we'll just my WASI app in there, and let's go and check out the code. Now that Visual Studio Code has loaded in, we see this is a normal console application that says hello world. I'm just going to modify it a bit, and I'm going to say, for instance, here, hello from, let's call this environment.os version.platform. And we all know that when that happens, hopefully you know, when that happens, when we run this whole thing called .NET run, we will get a hello from Win32NT, because I'm running now on Windows, right? So that is it. So let's keep that file as is, right? And remember, when we do that, what we have, it was actually generating as a kind of a DLL file and an exe file, right? So the exe file is the one that runs on your operating system. All right, so now making this a WASI file. There's some preview release from Steve Sanderson that includes a runtime for WASI. And we can add that package by just going into the package manager and type in .NET add package, and it's called wasi.stk, and it's a pre-release. And that will add the pre-release bits to your application. And if you're not sure what you're doing, just go add to your CS proj file, and here you will see and notice that there is a WASI SDK preview release version included in your CS project file. Now, when we run this again, just popping up the command line again here, let's run this again to see what happens, right? So if we go .NET run, we will see that's now hello from other. And why is that? Let's quickly see what happened here under the covers. Now we have, of course, we have a DLL and exe that's was compiled before, but now we have this WASM file here, right? This WASM file is now a single assembly version that is compiled for WASM. And it turns out, so this is what happens when you go .NET build. .NET run also calls .NET build if it hasn't built before. So it's the same result, right? What's nice about this is if you use a WASM compliant runtime like WASM time or WASMer, or there's many others, you can do cool things. So quickly jumping back into our PowerShell environment, we have WASM time. And WASM time, it's a runtime I've just installed. You can get it on the internet. You can go WASM time run, and you can run your assembly. So in this case, let's use WASM time, and we say WASM time run, which is the same as .NET run, but it's using a completely different runtime. So in this case, it's WASM time run, and we need to point it to a directory, which is debug net7, and we want to go to my WASI app.wasm. When we run this, it says hello in hello from other. Very cool. So this is now running completely outside the context of .NET even. It's taking your app, running it in a different runtime, a WASM specific runtime. Now you must be saying, well, this is great. It's great for console applications. What's in it for me? So bringing this to the server means that you can run it as a background process or even an API. But how do you get to it from an API? But before we move on, I just want to quickly show you something else. So if you hit your browser up to webassembly.sh, right, you will get to this site called WebAssembly. It's a command line application that just happens to run in the browser. But the idea is it's running a WebAssembly runtime. So you can use a lot of commands that's available here to your disposal. It's a way to test your application. The way to do that is it makes use of something called WAPM, which is WebAssembly Package Manager. It's the same as NuGet in essence, but it's specifically for WASM files. So in this case, you can go WAPM, and it says, okay, it has some support for list, install, upload. So now, in this case, let's go upload our WASM file. WAPM upload. And when it actually brings up the file browser dialog, you can go into your folder where it was defined, and here we will find our My WASI app. So in this case, we just upload that, and now we can go and run it by calling My WASI app. In this case, we'll say My WASI app, and it will say hello from other, which is perfectly cool. So this means this runs now in a different context. Now, my other question I put out there is, how do you get to it? Let's say you write a little API and you want to kind of expose this to the outside world as a container microservice-y kind of a thing. So think microservices, how do you get to that service? Let's quickly write a microservice using WASM and WASI. Going back to our code, one thing that we can remember is, let's quickly change this code a bit. We want to return a payload, right? So in this case, we'll just return a payload of system.json. So in this case, we will go content type is application JSON, right? Because of the spec of HTTP, we have to have a blank line between our header and our body. First, what we want to do is we want to have a variable, let's say this message, right? The message is a new message, and let's say, for instance, this is hello world, for instance, right? And we want to write this out to the console. So we can say console.writeLine. And we want to say, for instance, using system.json, we will use the serializer, the JSON serializer to serialize this message out to the real world. We just need to add a couple of usings here, system.text.json. That should kind of do the trick. Now running this again, I'm just going to quickly open up my terminal again, and I'm going to say .NET bold. Now it's compiling this application again. We'll see it's also compiled again in a WASM file. And when we run this thing again, we will then see there's something that's outputted as a HTTP message, right? So running this vanilla, we will see it's a normal application, a console application. It contains a header, a blank space, and the message. How do we put this into the context of WASI microservice? So it turns out there's a thing called WAGI, which is a WebAssembly gateway interface. It's a gateway component that will allow us to expose our application to the outside world using this gateway component, which is a WASM component as well, in essence. So quickly going back to the web browser, we have a repository open here from the WAGI guys, and WAGI is a WebAssembly gateway interface. This is the quick start. I will put the links in the comments down below, but basically it's a little CLI application that will help us expose this. So in this case, we have our application, but it works in this concept of TOML files. I have no idea what that means, but let's quickly check it out. Do that by just going back to our Visual Studio Code instance, and let's call this api.toml. So we have this thing called the API TOML file, and in here we need to specify a module first, and then we also need a route. In this case, we will make the route, for instance, API awesome. But also we need to tell it where the module is. So in this case, the module sits, so it's current directory /bin /debug/net7, I believe, /mywasiapp.wasm. We go and save that, open up the command prompt, and we go WAGI C, and we say it's API TOML. When we run this, hopefully we will get a application that says serving on 27001 3000 port, which is localhost. So let's quickly check out what was created for us. So if we go to this link, we see here it's not found, obviously because there is no endpoint listening. We made an endpoint called API awesome. When you do that, we'll get back an hello world endpoint. This is cool. This is actually insane. So it's a microservice that's running and it's working behind a gateway that serves as a .NET code that's running in a kind of a containerized environment, in this case using WebAssembly. But the bug doesn't stop there. Imagine you can serve this WASM file from a container registry like Azure Container Registry. Well, it turns out you can. Let's refer back to this website from dayslabs.io. It's a post from 2021, and basically it includes a kind of a CLI called WASM to OCI that you can use to push to a container registry. Now in this case, this example, you have a WASM file, and the WASM file gets pushed to a container registry over that location. And when it's pushed in your TOML file, you can now refer to an OCI protocol to go and fetch your image. Same as Docker and Kubernetes, all those kind of things does it. Which means this is kind of going towards the whole notion of microservices, how it's supposed to run. Again, I'm super excited about this news. I'm not an expert myself, but it was really, really fun digging into the deep dives and trying to figure out what is this WASI, what is WASM, what is WAPM, and all these WAGI things. It is really, really awesome, and I'm super excited about the future. Do subscribe to my channel, and thank you so much for watching. Take care.